So, good morning everyone. My name is Christianne Bretas. Today I will present the paper entitled Developmental Programming of Vascular Dysfunction by Prenatal and Postnatal Zinc Deficiency in Male and Female Rats. This paper was published in January of 2018 by a group from Argentina. Well, as I explained to you the message of WhatsApp, what is the reason for me to choose this paper? If you have noticed, this paper is not about cardiovascular function, cardiac function. The measure that they perform similar to us is the measurement of systolic blood pressure. They perform Western blot, but not using heart preparation. The focus of this paper is vascular function. But I think that this issue is important, and the main reason to choose this paper is the fact that they work with male and female rats, and they compare both facts. As we are studying gender medicine, I think that was interesting for us. So I think that this journal of Nutritional Biochemistry, has an impact factor about 4.5. This impact factor was, I think, A1, qualis caps, but as I have speak with you yesterday, we have to study the new qualis caps because things are changed. So we have to study if this journal in nutrition area, what is its qualis caps, okay? So, in the introduction, they talk about micronutrient malnutrition, and they said that's a growing public health problem. About 2 billion people worldwide living on unbalanced diets, and the most common micronutrient deficiency is vitamin A, folate, iron, iodine, and zinc. That is the issue of the paper. So they say that 17% of world's population has an unbalanced zinc diet. Okay? Epidemiological and experimental studies about the program says that fragile environments in gestation can lead to heart disease, kidney disease, and metabolic disease. And today they are speaking about gender difference, sex difference. So difference in this context between female and male. So the question is, could moderate zinc restriction during pregnancy be a nutritional result to fetal and postnatal development? And they continue that zinc is involved in vascular function and structure, as zinc can modulate nitric oxide production and oxidative stress. This picture is a summary of zinc and antioxidant and anti-inflammatory effect. So they show that zinc has the capacity to diminish reactive oxygen species, diminish as well lipid peroxidation. Nitric oxide synthase enzyme is zinc dependent. There are 3 isoforms of nitric oxide synthase: NOS1, NOS2, NOS3, that are known as well neuronal nitric oxide synthase induced nitric oxide synthase and endothelial nitric oxide synthase. What is the role of this enzyme? This enzyme converts arginine in the presence of NGPH and oxygen and citrulline and nitric oxide. So this enzyme is responsible to the production of nitric oxide. The function of this enzyme is enhanced by zinc. Okay? Nitric oxide, as I think you know, is involved in the diminishment of endothelial cell apoptosis, leukocyte adhesion, and platelet aggregation, as well vascular smooth muscle relaxation. This is the main effect that we'll study in this paper. Previous studies have shown that pre- and postnatal diet zinc restriction in adult male rats is capable of increased systolic blood pressure by the decrease of vascular nitric oxide synthase activity. This zinc restriction is capable of decreasing renal function, increasing renal oxidative stress. When I was reading the introduction, I have noticed that they have studied cardiac development. I think that is a paper that we should read because it's more related to things that we do. And what's the effect of zinc restriction in cardiac development? They saw a decrease of myocyte size, left ventricle wall thickness, and left ventricle contractility. They also have seen that hypertrophic remodeling of coronary arteries architecture. But the question is there a difference between male and female? Male females should be less sensitive to this micronutrient deficiency. Fetal programming have been studied in human and animal models, and studies in humans have shown that changes in vascular function and morphology increase the risk of cardiovascular disease in adulthood. Animal models have shown that low birth weight is related to endothelial dysfunction in children. Human studies as well. Low birth weight is related to endothelial dysfunction in children and young adults, and in animal models they have mentioned that protein and caloric restriction, similar to Yves' study in his doctorate, but looking the vascular system, they have described an intima media thickness remodeling, changes in the composition of the extracellular matrix of aorta and mesenteric arteries, as well as endothelial function. Males are not similar to females about reduction in vascular relaxation. There is a difference between the sexes. So the hypothesis of this study is 1. Moderate zinc restriction in male and female rats through fetal life, lactation, and or post-weaning growth induce alteration in vascular morphology and results in vascular disturbance in nitric oxide system, oxidative stress that can in turn predispose to the onset of vascular dysfunction in adult life. The second hypothesis is that normal zinc containing diet after weaning could not completely reverse the detrimental effects of earlier micronutrient imbalance on the vascular tissue. So, the hypothesis summarizing is prenatal and postnatal zinc deficiency cause harm in vascular system. They think that causes. And And if we try to equilibrate zinc plasma concentration given the animals a normal diet containing zinc, this supplement will not help to mitigate the harm that this worse environment in prenatal phase has caused. So the object of the paper is to evaluate thoracic and aorta of male and females of 6 and or 81-day-old rats exposed to zinc deficiency during fetal life, lactation and or postnatal growth in terms of morphology, function, oxidative stress, and nitric oxide system activity. About the methods, they say that the use of the animals and the methods applied are in accordance to local ethics committee. They say that the animals were maintained in the controlled environment, temperature, humidity, light to dark cycle. They said that the diet used except by zinc content was in the requirements according to AIN 93, as we have seen in other studies. They mentioned that female rats weighing about 300 grams were mated with males for 1 week. And immediately afterwards, as these female rats were randomly fed either experimental or control diet. Experimental is the zinc deficient diet. Control diet has the content of zinc, okay, during pregnancy and lactation periods. And the number of pups per mother is of 8, is higher than we use. But as we perform, they put 4 males to 4 females, okay? The 1 males and females. This slide shows the experimental design. It's important for us to understand what did they do. So, Wister rats were mating for 1 week. After this, the mother was separated in cages, and we have 2 groups. Mother receiving control diets with 30 ppm of zinc. This is a unit of concentration, 30 parts per million. I don't know if everybody have, I think Samuel has already heard about this unit of concentration, IVs, I think, but I don't know if everybody is aware about this. And the experimental group, mothers have received low zinc diet, zinc concentration about 8 parts per million. So 1/3 of the content, zinc content compared to control mothers. 1/3, 3 parts. Day 1 is the day of the birth of male and females. So as we have discussed, the offspring was adjusted by 8 pups per mother. So the pups were identified as control and low zinc group. Control male, CM, control female, CF. Low zinc groups, LM, males, LF, females. So we had the lactation period. The weaning was at day 21, as we perform, and after day 21, we now have 6 groups, not only 4. We have 6 groups of pups. Why we have now 6 groups? Because after weaning, they will offer to the pups normal zinc diets or low zinc diets. This control receives normal zinc diets. These animals receive control zinc diet and their mothers have received normal zinc diets. Okay? No, Camila? Okay? These animals are from mothers that received deficient zinc diets. But LCM and LCF received normal zinc diet after weaning. Their mother was deprived of zinc, but after weaning, their diets had normal zinc content. LLM and LF groups received zinc deficient diets. So their mothers have received zinc deficient diets and their pups also receive zinc deficient diets after weaning. Okay? Any doubts about the experimental groups? Well, the animals were evaluated at postnatal day 6 and postnatal day 81. In these ages, they have performed euthanasia to collect blood samples, and they measured zinc content in these blood samples, okay, by atomic absorption spectroscopy method. They also collected tibia samples to evaluate growth, okay, and they have collected as well thoracic aorta tissue to evaluate in these ages oxidative stress and nitric oxide synthase activity. Some measures they just perform with animals at postnatal day 81. And I will explain later, okay? This method was applied to the samples collected in both ages. Before sexual maturation, I think that's important for you to pay attention on that this day is very early, and this age is after sexual maturation. I won't explain every technique in details because I think that most of them we perform. But I think that it's important to read the method because they have interesting insights about Western blot. When I present the result, I'll try to point the thing that I think that it's important, okay? But I won't explain the Western blot, how they measure systolic blood pressure, but I think that's important to read. They say that before measure the systolic blood pressure, they put the animals in a different room for 40 minutes, maybe, as we know that this technique is very hard to perform because the animals' stress can disturb the measurements. I think that could be an interesting tip that they provide. But some techniques that are different for us, I think that is interesting to talk a little bit. So when they measured aortic nitric oxide synthase activity, what is involved in this measurement? To evaluate enzyme activity, we can measure the substrate decreasing or the product increasing. In our lab, we have some enzyme activity measurements, sodium potassium ATPase, SERC ATPase. We measure the product. So as the enzyme works, the concentration of the product rises. Okay, and they use this a similar method to evaluate nitric oxide synthase activity. But how can they see the rise of the product? Because we use colorimetric method. ATP that is cleavated. We have the liberation of inorganic phosphates that reacts in the medium that the reaction medium, and we see a blue color directly related to inorganic phosphate concentration. And we use a spectrophotometer to review this reaction. Here they use a substrate labeled with carbon 14. Is a radioisotype. So when they measure the product, they will measure the product also labeled with carbon 14. And there is an equipment, liquid scintillation equipment that can read the radioactivity of carbon 14. Okay? It's not an easy thing to perform because it is a radioisotype, but it's also possible. And it's interesting to discuss the pharmacological tools that they use. This is very important because they measure the basal nitric oxide activity. We have, as I have mentioned to you, neuronal nitric oxide synthase, induced nitric oxide synthase, endothelial nitric oxide synthase. Maybe it's every isoform of nitric oxide synthase mixed. How can they see just one? So they use these pharmacological tools and they evaluate using these pharmacological tools just animals, just the samples collected of animals with 81 days of age. Okay? So aminoguanidine is a substance that inhibits induced nitric oxide synthase. So the measure that they will read in the presence of this agent is of others nitric oxide synthase, but not of this. Okay? 7-nitroindazole is a specific inhibitor of neuronal nitric oxide synthase. As nitric oxide synthase depends of calcium calmodulin complex, they also use calmidazole to inhibit calcium calmodulin. And they use nitroarginine methyl ester to inhibit nitric oxide synthase. This agent inhibits all the three isoforms of nitric oxide synthase. Did you understand the role of these agents? to understand the result, it's important to pay attention. Which agent inhibits which isoform, okay? With the animals, older animals, the experiment that they performed just with the older animals was systolic blood pressure records that I ask you to read carefully, and after euthanasia. They remove thoracic aorta tissue to evaluate histology, nitric oxide expression, and to perform vascular reactivity studies. Well, how can we perform vascular reactivity study? It's similar to Langendorf that we program to perform in our projects. So, male and female rats about 8 days old was euthanasiated and thoracic aorta was removed. This tissue was dissected. They removed the perivascular tissue and they connected the aorta rings. They cut aorta in rings and put in this place that can measure the stretch of the aorta. This is connected with a tension transducer. If aorta contracts, the tension transducer will capture this, you record this tension, okay? Of course, aorta is not loose here. Here we have a bath with crabs, similar to the crabs that we work. This solution is bubbled with oxygen and CO2, okay, to keep this tissue alive. This tissue will be alive outside of the body of the animal, okay. They apply a tension of 1 gram in this tissue and wait for 1 hour to perform the experiment, because we have to stabilize this tissue in this system. Okay? Which are the protocols that they perform? They perform a lot of things. So it's important for us to see very calmly what they do. First, they perform a control stimulation, raising the potassium concentration in the crabs. Okay? The concentration of potassium in this crab is increased compared as we work. Okay? The second protocol they perform to evaluate endothelium viability. How can they evaluate endothelium viability? First, they pre-contract the aorta with phenylephrine. Then, they put acetylcholine to see the relaxation promoted by acetylcholine. The third protocol, they use to evaluate relaxation response, not just to acetylcholine, but também sodium nitroprusiate. I will explain the mechanisms of action of all these agents that I am mentioned to you. And they perform this protocol with endothelium presence and with endothelium removed. They remove the endothelium before perform the third protocol. And in the absence of the endothelium, they put first phenylephrine and then acetylcholine, and we have increased concentration of acetylcholine. They didn't work with one concentration. They began with 10 minus 10 to 10 minus 3 molar. Okay? And in the presence of endothelium, they perform it in the presence or in the absence of L-name, 10 micromolars. L-name is this agent, L-nitroarginine methyl ester, L-N-A-M-A, L-name, okay? L-name is this substance, okay? In the absence of endothelium, they put phenylephrine, increasing concentration of acetylcholine, or sodium nitroglycerate with increasing concentration as well. The fourth protocol, they perform constriction response, they evaluate constriction response to angiotensin II and to caffeine. They evaluate the angiotensin II effect in the presence of endothelium. And they work with angiotensin concentration beginning 10 minus 10 to 10 minus 7 molar. And the effect of caffeine in a calcium-free crabs, they evaluate in the absence of endothelium. Well, about statistical analysis, they work with objective data and subjective data. With objective data, they apply Shapiro-Wilk tests to check normal distribution, and if the data are normally distributed, they express this data as mean and standard error of the mean. They perform two-way analysis of variance, followed by Bonferroni post-hoc tests for multiple comparisons. But they mention that they evaluate diet versus sex effect in both ages, and if diet versus sex interaction is not significant, they just compare main effects. But if diet versus sex interaction was significant, they evaluate the compared groups of interest. I think that was an interesting thing for us to pay attention in this. Subjective score, subjective data is score that they measured in histology studies. And with this type of data, they express as median and range, not mean and standard error of the mean. And they applied non-parameter Kruskal-Wallis test followed by Dunn's test. And the accepted significance was P less than 0.05. Okay? They also mentioned that concentration response curves obtained in vascular activity studies were analyzed using a signal fit curve with variable slope to obtain maximal response. This parameter, Emax, is a classical parameter of pharmacodynamic studies, and minus log of EC 50. Okay, they present the data not as EC 50, but minus log of EC 50. Minus log is this P that they put here. Okay, and this measure is used to evaluate potency of the substance. Okay, I don't know if everybody knows how to estimate EC50, but EC50 is the concentration of the agonist that promotes 50% of maximum effect. Okay? And the max of a single dose of caffeine was normalized by the maximum concentration contraction, analyzed by the simulation with chloride potassium 90 millimolar. Well, table 1 shows body weight, tibia length, and serum zinc concentration at 6 days of life. So we have control groups, male and female, and low zinc diet groups, male and female, the pups. Okay? I think that's important for us to also pay attention the number of observation. So the number of the animals from each group is 12 in these measurements. Okay? I think that's important because we have situation that you ask me, oh, what will be the end of this experiment? We have discussed that we have a reference that points to at least 5, considering 10 animals, but is also adults. So I highlighted the number of observation each experiment that they perform. Okay, so this biometric measures and zinc concentration in the serum, they have evaluating 12 animals from each group. Well, the star is related to statistical difference having CM group as reference. Okay? So we can see that compare LM and CM groups, the LM group have presented lower body weights and lower zinc concentration in the serum. So here we can say that the experimental model was validated because they see that the animals from mothers that were zinc restricted present a decreased zinc content in their serum. Okay? And maybe the growth of the animal is also harmed. Okay? Now, this symbol across is pointing difference, statistical difference, has CF group as reference, female control groups. And we can see that females from restricted mothers have present, as seen in males, lower body weights and lower serum zinc concentration. So here we don't have difference between male and females. Okay? They also compare males and females, and they saw that animals from restricted mothers, we have females presenting a body weight inferior to male groups. Now we have body weight, tibia length, serum zinc concentration, as well as systolic blood pressure of these groups at about 8 days of life. Now we have 1, 2, 3, 4, 5, 6 groups because, as I explained to you, after weaning, some animals were also zinc restricted. Okay? They put here that sex versus diet interaction was considered significant in this data, and they also evaluated 12 animals per group. Well, the star is pointing to a statistical difference comparing the other group with male control group. And what can we see? Comparing low zinc males with this control group, we see that the body weight is decreased, tibial length is decreased, zinc concentration is decreased, but systolic blood pressure is increased. Okay? Comparing LCM group to control group, they also see that body weight is decreased, tibial length is decreased, serum zinc concentration was normalized, but systolic blood pressure is increasing despite serum zinc concentration. Okay? And they also have noticed that comparing control male and females after sexual maturation, females that the mother received normal zinc diet and they receive normal zinc diet, the females are weight less than the males. And the tibial length is also diminished. But this is an effect of the sex. After maturation, we all know that females are smaller than males. Now the reference group is this low mother, low pups zinc groups, males of these groups. And we can see that body weight of the males that receive normal diet after weaning and the mothers was zinc deprived presents, a higher body weight, not a lower body weight, it's a higher compared with this group. Okay? And comparing this group with the same group but females, we notice a decreased body weight, a decreased tibial length, and a decreased systolic blood pressure. This is an interesting data. Okay? Now the reference is this LCM group. Males that are from deprived mothers but that receive normal zinc diet after weaning. Compare with the respective groups of females, we can see that the body weight is diminished and tibial length is also decreased. Okay? But comparing this group with the males that continue to be zinc deprived, they see that the serum zinc concentration was different. So they are proving that the normal diet after weaning are normalizing serum zinc content. But maybe the harm that the deficiency of zinc in prenatal stages are not mitigated. Okay? Now the reference group is female control, and we can see that the females that were deprived of zinc in both moments of life or just in the prenatal stages presents lower body weight, lower tibial length. Okay? But as we have spoken in the males, the zinc concentration is normalized if after weaning we provide the animals a normal diet. And the last comparison, I think, has this group as reference. And just point that the normal zinc diet after weaning normalizes serum zinc concentration. So this is not the doubt. If we provide the animal with normal zinc diet after weaning, serum zinc concentration will normalize. But they evaluate if other effects will be normalized as well or not. So, the diminution of tibia length observed in males and females indicates a growth delay. I have explained that they use tibia length to evaluate growth evaluation. So, this data points to growth delay, and they discuss that zinc can stimulate cell proliferation by upregulating gene expression of the DNA synthesizing enzyme, this enzyme, and by stimulation synthesis of the growth hormone and insulin-like growth factors. The rise of systolic blood pressure in males, they discuss that human studies report an inverse correlation between the level of arterial pressure and serum and hair zinc concentration. And they also mention that sex difference observed in systolic blood pressure are consistent with findings across diverse development programming animal models, as we observe in Graciele studies, showing that female offspring exhibit a protective status regardless of the species or specific fetal insults. So, as we have discussed many times, maybe the estrogen protective effect. This table has morphometric parameters, elastin fibers, and collagen in deposition in aortas in the animals at 81 days of life. So we have 6 groups, and they present the ratio between tunica media area and lumen area, perivascular collagen area and lumen area, elastin fibers, and collagen fibers in tunic. So the score that I have mentioned to you before. So they didn't see any difference about elastin fibers. Don't have any statistical difference. And here are the images of the lamina. But they observed that about collagen fibers, the males that were zinc deprived both in prenatal and postnatal period have a high collagen fibers in tunica media compared to the control. Okay? So they discuss only males have shown an increase in collagen content in tunica media that could be an early sign of vascular remodeling associated with higher tension stress due to the chronic increase in systolic blood pressure that was observed in the previous table. Okay. Now we have the evaluation of oxidative stress. Graphic A and B, they measure malondialdehyde by T-bars technique as you before. And graphic C and D, they evaluate superoxide production. Graphics A and C are related to animals at 6th day of life, and graphics B and D are related to adult animals. Okay? So graphics A and B, we have just 4 groups, control groups, male and female, and deprived groups, male and female. But in other animals we have 6 groups because that's the difference about zinc diet after wean. Okay? What they observed, pay attention that in this technique they use the 6 animals per group. In histology studies they use also 6 animals per group. Okay, so the number of observation that they use is similar of us. And what did they see when evaluate the oxidative stress? The star compares groups with control groups, control male groups. Okay? So we can see that zinc deficient in prenatal days is responsible of the increase of malondialdehyde, represent an increase of oxidative stress. Okay? But no difference were observed between these two groups about superoxide production. And we can observe that control females have inferior superoxide production compared to respective males. Maybe it's an advantage of being female. Okay? Now the reference group is female control. And we see that the group that the mothers were deprived of zinc in the gestation and lactation presents a higher malondialdehyde concentration compared to control. We also can observe that superoxide production in this female obtained from deprived mothers were also higher than the control group. Okay? They discussed that the increase of vascular oxidative stress observed only in 6-day-old rats could contribute to the reduction of nitric oxide viability or to endothelial nitric oxide synthase uncoupling. Notice that in older animals, no difference were observed. Activation of antioxidant defense is in the aortic tissues of male and female deficient rats, allowing them to maintain the levels of reactive oxygen species involved in vascular superoxide anion production and in lipid peroxidation. Compensated oxidative state would prevent an even lower availability of nitric oxide in aortic tissue. Since the distribution of zinc and the antioxidant capacity vary greatly among different organs, tissues and organs, the impact of zinc deficiency on oxidative stress is clear tissue dependent. Similar results they have observed in cardiac tissues of zinc deficiency rats. The paper that I have mentioned to you that I think that's important for us to read. Now, they evaluate nitric oxide activity in the absence of any inhibitors. Okay? Graphic A is in samples obtained of 6-day of life animals, and graphic B from the older animals. Observe that the number of observation was also 6. The star compares the group with control males, and we can observe that in 6 days of life, nitric oxide activity was lower in this LM group compared to respective control. We can see that in older animals, not only deprived males present a decreased nitric oxide activity compared to the control. Pay attention that the control females present a higher nitric oxide activity compared to control males. Maybe this data points protective effect in females compared to males, because basal nitric oxide activity is higher. Now the reference group is this control females, and we can see that in younger animals, zinc deficiency diminish nitric oxide synthase activity, as well as in older animals. Zinc deficiency just only in the prenatal days or at weaning, we have these both groups presenting lower nitric oxide activity compared to respective control. Now, the reference group is this groups of males that were zinc deprived all moments of life. And we can see that comparing the respective female groups, these females was also zinc deprived in all moments of life, but the level of nitric oxide activity is higher comparing to males. Okay? This comparison now has this group as reference, the males that after weaning received normal zinc diets, and compared to the respective group of females, the females, one more time, presented higher nitric oxide synthase activity compared to respective males. So, even though zinc deficiency diminishes nitric oxide synthase activity, both females and females, males present a higher, present a higher nitric oxide synthase activity compared to males. Did you understand the effect of zinc deficient and the effect of the sex? They discussed that the decreased aortic nitric oxide synthase in males and females at early periods of postnatal life persisted until adulthood, as we have seen. Fat injury can program the functional capacity of nitric oxide system in adulthood. And moderate zinc deficiency during fetal and postnatal growth induce similar effects in renal and cardiac nitric oxide systems. Now we have the data using those pharmacological tools that I have mentioned to you. So here we have just males, here we have just females. Okay? These animals are adult animals, and the number of subjects per group is 6. Okay? The first column here, first bar, I think, refers to basal activity. This number is the same of this. Okay? Basal activity. In the absence of any pharmacological tool, any substance. This second bar, they use the inhibitor of induced nitric oxide synthase. This bar refers to the inhibitor of neuronal nitric oxide synthase. This bar that is vertical, we have the mixture of these two inhibitors. So in this situation we have both induced and neuronal nitric oxide synthase inhibited. Okay? And this bar refers to the effect of alanine that inhibits the 3 isoforms. So, in the presence of alanine, we have the inhibition of induced, neuronal, and endothelial nitric oxide synthase. And the last one is the substance that we have mentioned that inhibits calcium calmodulin. So, the first comparison is with control groups, okay? And we can see that the private groups present reduced nitric oxide activity, okay, compared to this group. The same thing that we have discussed a few minutes ago, okay? They repeat this data here. Now, the comparison is with this group in the presence of confusion. And they see that compared with this group, we have in the presence of alanine and calmidazolium a decrease of nitric oxide synthase activity. Just in this condition. They didn't see difference when just induced nitric oxide synthase was inhibited. They didn't see difference with just neuronal nitric oxide synthase was inhibited. And they didn't see difference when both induced and neuronal enzymes were inhibited. They also saw difference in the presence of alanine and calmidazolium, a situation that endothelium nitric oxide synthase is inhibited. So they address that the nitric oxide synthase that is inhibited effect in this model is the endothelium isoform, not induced, not neuronal. Okay, this is the main enzyme involved in nitric oxide production in this case, both in males and in females. Now we have the results obtained after Western blot assays, and here we have the expression of endothelium nitric oxide synthase normalized by beta-actin as we perform, okay? And here in the second graph, graphic B, we have the ratio between phosphorylated endothelium nitric oxide synthase, that's an active form of this enzyme, and non-phosphorylated nitric oxide synthase. If I understand well, they didn't use in this to calculate this ratio the normalized expression by beta-actin. I didn't understand that that they performed the ratio with beta-actin before to put here. I think that they analyzed and the number obtained by phosphorylated and the number obtained by non-phosphorylated, they calculate the ratio. Because here what we do, I think, we first normalize phosphorylated enzyme to beta-actin, alpha-tubulin, and then we perform the ratio. Maybe they didn't do that because they used in both cases beta-actin. But I think that it's impossible for them to use the same membrane, because here we can see that the molecular weight of phosphorylated form is the same molecular weight of non-phosphorylated form. They didn't mention to perform the strip, but the only way to use the same membrane is to perform the strip. But they didn't mention it. Different for phospholamban that we use, these two forms of the protein has the same molecular weight. But what did they see in these animals, adult animals, 6 samples per group? Comparing to male control, we observe that zinc deficiency at all periods of life or just prenatal days diminish endothelium nitric oxide oxide synthase expression. But when we compare the males zinc deprived with the females zinc deprived, we observe that the females have a higher expression of endothelial nitroxide synthase. Comparing the females that were zinc deprived just in the earlier moments of life with the respective males, we also observe that the females present a higher expression of endothelial nitroxide synthase. And no difference were observed about the ratio between phosphorylated and non-phosphorylated forms of this enzyme. And they discuss that the diminition of aortic endothelial nitroxide synthase activity could be related to the reduced expression of this protein. It's very understandable, this result, but not to change in the activation of this enzyme, because there was no difference between phosphorylated and non-phosphorylated form. Endothelial nitroxide synthase presents different post-translational regulatory mechanisms, including the phosphorylation that was studied here, and the diminishing of this enzyme activity was observed to be in a sex-specific manner, and these effects persist until adulthood. The increase of this enzyme activity expression in adult females suggests a protective status, and they address this protective status to the effect of estrogens and progesterone. So, before sexual maturation, in 6 days old rats, we didn't see this, because gonads are not fully matured and the levels of these hormones are much lower compared with adults. It's something that we want to perform in our studies. Compare the 9-day-olds, 150-day, 1 year old, to the 30 days old before maturation, sexual maturation. Okay? It's something that we want to do as well to explain our results as they are performing here. Now we have the data obtained by vascular activity studies. So table 4 is showing the response to different vasodilator or vasoconstrictor agents in aortic ring with intact endothelium, is the E+, and denuded endothelium E- at 81 days of age. All experiments were performed with 6 animals per group. First, what we can observe, that when they put acetylcholine and adenine in aortic rings that present intact endothelium, we have a small effect. Look here. Small effect, 6, 4, 4, 6, 9, 8. Emax about this number is very low. This is the presence of endothelium. In the denuded endothelium, just acetylcholine, we also see that the effect is very low. Okay? Why this? Why we have these results? So here we have a figure that illustrates what is happening. Here we have endothelium cell. Here we have this muscle cell. The experiment was to measure the tension of this group of cells. Okay? But we are discussing that some measure was obtained in the presence of endothelium, and others were obtained in the absence of endothelium. Okay? What is the role of the endothelium and what acetylcholine do? So we have acetylcholine receptors in the endothelium, not in the smooth muscle. Okay? Here we have a muscarinic receptor that is a metallotropic receptor coupled to protein G key. Okay? When acetylcholine binds in the site of this receptor, we have a transduction of the signal that culminates with an increase of cytosolic calcium. What does calcium do in this cell that's not a smooth muscle? Is endothelium. Calcium stimulates nitric oxide synthase, the enzyme that we are studying, the activity, that we are studying the expression. And as we have discussed, this enzyme catalyzes the conversion of L-arginine and nitric oxide. So if the endothelium is maintained, we have this occurring, nitric oxide is produced, and as nitric oxide is a gas, it diffuses to this muscle cell. And what is the role of nitric oxide in these cells? This gas stimulates guanylate cyclase, an enzyme that produces cyclic GMP from GTP. And the increase of cyclic GMP in these muscle cells leads to relaxation. So if the endothelium is preserved, we expect that acetylcholine leads to relaxation. Okay? So we are discussing that in the absence of endothelium, we don't see relaxation effect of acetylcholine. Okay? Everybody understand? What alanine do? As the figures show, alanine is a substance that inhibits nitric oxide. Despite the presence of endothelium, if I am in the presence of alanine, even though acetylcholine binds to its receptor, I have nitric oxide synthase inhibits, so the nitric oxide production will be harmed. Okay? So this explains why, even though in the presence of the endothelium, acetylcholine does not show its relaxation effect in the presence of alanine. Now we have the evaluation of acetylcholine effect in the presence of endothelium, and now we have increased concentrations of acetylcholine. Okay? Increased concentrations of acetylcholine with preserved endothelium to see acetylcholine concentration dependent effects. We expect that if we have more acetylcholine, its effect will be higher. When all receptors is occupied with acetylcholine, we have the maximum effect. And here we can see the maximum effect of acetylcholine. And here we have minus log of EC50 that we have also discussed, that is the concentration of acetylcholine that will produce 50% of maximum effect. And using these control male groups as reference, we can see that zinc deficiency diminish the maximum effect of acetylcholine. Okay? Why zinc deficient is diminished the maximum effect of acetylcholine? Maybe because zinc deficient leads to the diminition of the expression of nitric oxide synthase and its activity. Now the reference group is the male deprived all life with zinc, and compared to the respective female groups, we see that female groups, present a higher maximum effect of acetylcholine. Maybe because, as we have seen, even though they are deprived of zinc, females present a nitric oxide activity, synthase activity higher and expression. Now, using these control female groups as reference, we see that as observed in males, zinc deficiency diminish the maximum effect of acetylcholine. So, we have also shown that acetylcholine binds to this receptor, activates a transducer signal that involves calcium raise, nitric oxide synthase activity, the production of nitric oxide to cause relaxation. But if this enzyme is less expressed, its activity will be diminished and the acetylcholine effect will be diminished. Now we have the effect of sodium nitroprussiate in the denuded endothelium. So here we have Emax and minus log of EC50. And we didn't see any difference here. Deficient animals, control animals, males, females, we didn't see any difference. Just here that female deprived, zinc deprived, presents a higher minus log of 50 compared to respective males. But we don't have important effects. Why this? Sodium nitroprussiate is a nitric oxide donor. In the experiment, what I tell you, that was performed with denuded endothelium. This is not present. We have only this. But sodium nitroprussiate is a nitric oxide donor. So, sodium nitroprussiate can lead to vasorelaxation independent of the endothelium. And this result points that the problem is not necessarily in the smooth muscle. The problem is in the endothelium. Okay? So they discussed that the preserved action of nitric oxide in smooth muscle and the lower endothelial production of or bioavailability of nitric oxide could be responsible for the lower vasodilatory response to acetylcholine. They also say that as when evaluating vascular oxidative state, it was not observed changes in NADPH, oxidase activity, or interbars levels in adult male or females of rats submitted to zinc deficient. It could be postulated that the lower vasodilator effect of acetylcholine would be caused mainly by a decrease in nitric oxide production than a decrease in nitric oxide bioavailability. This would also be diminished if the oxidative stress would be increased. Okay? And this experiment of nitric oxide production and consequently decrease in acetylcholine vasodilatory effect may be related to an increase in blood pressure. But notice here, they only evaluate systolic blood pressure. They didn't evaluate mean blood pressure or diastolic blood pressure. And why is it important to mention it? Because systolic blood pressure is related to cardiac frequency, cardiac contractility, okay? And aorta is involved to vascular resistance. So this data of vascular reactivity to be paired to the measure of blood pressure would be necessary to measure diastolic blood pressure. Systolic blood pressure is not related to aortic tension. Okay? So they can't address the systolic blood pressure has raised because vascular reactivity was, relaxation was decreased. They can't address this. But they say that maybe this effect on systolic blood pressure is related to renal and cardiac dysfunction observed in male rats in previous studies. That's important for us to read. And here we have now the measurement of angiotensin II effect in intact endothelium and caffeine effect in denuded endothelium. What these agents do? First, now we have a figure a little bit different from the others that I have projected. But here we also have a muscle cell. Okay? We see the plasma membrane with receptors linked to protein GQ, just like we have seen before. And alpha-1 receptor, that the physiological agonist is phenylephrine, as well as AT1 receptor that mediates angiotensin II effect. Both receptors are metabotropic linked to protein GQ. To measure acetylcholine or sodium nitrocruciate vasodilatador effect, previously we have to contract the aorta. If we didn't pre-contract the aorta, how can we see relaxation effects? So that's why they use phenylephrine before put acetylcholine or sodium nitrocruciate. So these two agonists, when binds to their respective receptor, stimulate protein G that stimulates an enzyme here identified as PLC, phospholipase C, that cleavage membrane phospholipids and produce IP3. Everybody knows IP3, I expect. So this molecule finds a receptor specific for it in the sarcoplasmic reticulum membrane. This receptor is a calcium channel. So when we have IP3, this calcium channel is stimulated and calcium goes to cytosol. And when calcium raises the cytosol, if it's a muscle, we have contraction. So that's why phenylephrine causes contraction. That's why angiotensin II causes contraction. Okay? But maybe zinc deficient can impair this pathway. Let's see. And what we observe, taking this group as reference, we can observe that angiotensin II effect is diminished when the animals were exposed to zinc deficiency. And I think that this effect was observed mainly in males, but in females we also observe that the zinc deficiency leads to a decrease in angiotensin II effect. Okay, what is the effect of caffeine? Caffeine is an exogenous substance that can activate ryanodine receptors. I was curious why they use this pharmacological tool here, because I think that in this cell the calcium is raised in the cytosol mainly due to IP3 effect, not ryanodine receptor, but they see an effect. So caffeine stimulates ryanodine receptor. I think that everybody is familiar with ryanodine receptor as well. Physiologically, what happens? We have calcium channels in plasma membrane that is activated when the cell has the membrane potential increased. As calcium has a higher concentration in the extracellular medium compared to cytosol, when this channel opens, calcium enters in cells. And this external calcium is important to activate ryanodine receptor and promote calcium flux from sarcoplasmic reticulum. So when we use caffeine, we didn't need the effect of NTCC to promote calcium flux from sarcoplasmic reticulum. Caffeine activates directly this ryanodine receptor. Okay? And what we can see here. So we can see that in the absence of the endothelium, putting caffeine in the medium, the contraction of the muscle is also diminished in animals that were zinc deprived. Here in males we can see this very clearly. But we can also see that comparing control males with control females, caffeine effect is higher in females compared to males. Comparing groups, both males and females that were zinc deprived all life long, we also see that caffeine effect in females are higher than in males. And comparing male and female groups that were zinc deprived just in early days of life or prenatal life, one more time, females present a higher caffeine effect compared to males. But as observed in males, caffeine effect and angiotensin II effect may be harmed by zinc deficiency. So they discussed that the decreased vascular contractile response evoked by angiotensin II could be associated to different factors like changes in affinity to angiotensin receptors, they didn't evaluate this, or the expression of contractile proteins or in calcium availability. Since no difference in aortic constriction with KCL were observed, the impaired angiotensin II response could be due to alterations in intercellular calcium mobilization via IP3 and not in extracellular calcium trial by FTCC, as we have discussed. The reduced contractile response of aortic rings to caffeine indicates a lower mobilization of calcium from the sarcoplasmic cortisol during smooth muscle contraction via ryanodine receptors. And I was wondering, maybe we had a reduced sarcoplasmic reticulum calcium content. They didn't mention that, but as caffeine effect and angiotensin II effect are both diminished, the problem may be the content of calcium in this sarcoplasmic reticulum. So they conclude that this study strengthens the importance of balanced intake of micronutrients, prenatal and postnatal growth. Dietary zinc restriction during fetal life, lactation and/or post-weaning growth programs lower contractile and arterial-dependent relaxant response in thoracic aorta of adult males and females. They also conclude that cellular mechanisms may include a reduction in arterial nitroxide production since in early periods of life, as well as change in cytosolic calcium bioavailability during smooth muscle contraction. Inadequate zinc diet during postnatal life could not reverse the detrimental effect of this early micronutrient deficiency on vascular tissue. And they also conclude that the results show sex difference in the vascular effects of this nutritional injury.